Welcome to week 4 of Integrated Math 2. We're going to talk about dilations and similarity this week. Our first question is, what does it mean to be similar? Okay, similar, so look at like this circle and this circle. What do they have in common? They're the same shape, but they're definitely not the same size. So similar means same shape, but not the same size. Okay. And a dilation, you've probably heard, if you go to the doctors and you have, a dilation, and if your eyeball, right, it gets bigger or smaller, that's an eyeball. Your pupil dilates. Well, a dilation is either an enlargement or a reduction. And the scale factor, which we're going to talk about, is usually referred to as K. We can't use S because S is used for other things in math. So the scale factor, when it's enlargement, so if you talk about something, okay, if we have two things that are the same size, this is called 1 to 1, so they're the same. But if I'm going from, say, 1, let's say, to 5, this is a 1 to 5 scale factor. It got 5 times bigger. So an enlargement is your K value, your scale factor is larger than 1, and in a reduction, your K is less than 1. That's important to note. All right, let's look at if we enlarge or dilate an object, we can use a scale factor. So we're going to start with our original shape. And our original shape here, I'm going to just highlight in yellow, just so they're obvious that that's our original one. That's the one we're starting with. Now, if we are going to stretch it, and this is called a rubber band chain. So imagine if I had a rubber band that was tied here, and I'm starting to pull this side. This is the original size. If I pull it here, okay, let's see, I'm going from 1, 2, 3. This is over 3 up 2, right? Over 3 up 2. So if I set it up like a slope, rise is my 2 over run. And then if I stretch it to here, what's my new rise? My new rise comes all the way up to here, 4 over 1, 2, 3, 4, 5, 6. 4 over 6. So notice these are the same. They're going to have the same proportion. 2/3 is equal to 4/6, or you can think about it, 4/6 reduces to 2/3. But what's my scale factor? What did I have to multiply this by to get to 4/6? What did I multiply 2/3 by to get to 4/6? By 2. I multiplied both the top and the bottom by 2. So this is going to be my new point, A. I stretched A this way, twice as large. And if this is my original one, it's just A, but then my new image is A prime. So same with B. Do you see how B is rise over 2, left 1? So if I double it, up instead of up 2, I go up 4, and then it's going to the left 1, I go twice. This would be B prime. That little asterisk is called a prime. Same with C, I'm going down 2, left 2, so I would go down 4, 1, 2, 3, right, or left 4. This would be C prime. And then D, over 1, down 2. So when I double it, going twice as big, instead of going over 1, I'm going to go over 2. Instead of going down 2, I'm going to go down 4. This would be D prime. So my enlargement would look like this. Okay? And I can stretch it even further to 3 times as large, and then I would be here. But my graph doesn't go that far, so we're just going to stop right there. Okay? This is an enlargement. Now if the red, what's the drawing in red, was my original, and I shrunk it, it would be 1/2, because this is half as big. All right? Let's look at the next one. Let's try plotting A, B, and C with vertices. The red shows up much better. 0, 0, 3, 4, is B, and 3, 0 is C. So here's ABC, right? This is my original. And what do we want to do with that? Using the origin as the point of dilation, so this is where we're going to like place the rubber band and then stretch. Enlarge by a factor of 2. Okay, we got this. So if A is at 0, 0, and I multiply 0, if I take 0, 0, and I multiply it by 2, my new point is just going to be 0, 0, right? It's not going to change. All right? Let's look at this. So point A, and then this is A prime. It's still going to be at the same point. B is 3, 4, and I'm going to multiply that by 2, and that's going to give me my new point. 3 times 2 is 6, 4 times 2 is 8, and then that's going to give you B prime. So watch this. Let's go to 6, 8. I'll show you. 6, 8 is right here. This is B prime. Let me show you why I know that's double. One, I could do it mathematically, or if I do it like I just did the problem above where we talk about going twice as far. See how I went over 3? Well, I'm going to now go over 1, 2, 3, 4, 5, 6, which is twice as far. And then instead of going up 4, I'm going to go up 2 times because our factor is 2, or our K equals 2, and that gives me to 8. So then using that, C is 3, 0. If we multiply that by 2, we're going to get 6, 0, and that's our C prime. So 6, 0 is right here. There's C prime. And we have now enlarged that triangle by 2 times. All right? What are the side lengths of the original triangle? Well, I guess I should have left space here, but that's okay. We're going to move over here. We have the side lengths AC. A to C is 3. A to B, is this one? I'm going to have to figure it out. C to B equals 4. Well, and you might remember the 3, 4, 5 triangle, but if not, I need to find this length right here. This is 3 and this is 4. So over 3 up 4. To find this side right here, we have to do the Pythagorean theorem. 3 squared plus 4 squared equals C squared. The C is always the longest side of the triangle. So we're going to get 9 plus 16 equals C squared, or 25 equals C squared, therefore C equals 5. So this length is 5. And then, so what do you think the sides of the enlarged triangle are? A, B, C. Okay, we see that A prime to C prime, because A prime is right there also, A prime. A to C is 6. And I'll save A to B for last. I don't know why I did it in this order. C prime, B prime. That's this distance here is 8. And then what do you think this one's going to be? Do you see what's happening? 3 times 2 is 6. 4 times 2 is 8. Oh, you know that this is going to be 10, and I can just prove it right here. 6 squared plus 8 squared equals C squared. 36 plus 64 equals C squared. Add these two together, this makes 100 equals C squared. When you take the square root of both sides, which is what I did up here, you're going to get C equals 10. And that's what we said it was. Oh, now it says calculate the area and perimeter. Okay, so the area, why didn't we can do the perimeter of the small one? Let's do both. Let's do perimeter of triangle ABC, which is the 3 side lengths, 3 plus 4 plus 5, 9 plus 5 equals 14. And then the perimeter of triangle A prime, B prime, C prime equals 6 plus 8 plus 10, which is 9, 10, 11, 14, is 24. Did I add that right? 7. Oh, this is 12. Sorry, I added wrong. Well, that makes sense, right? Because 12, and do you know how I noticed my mistake? because I knew that I doubled it. My K factor, my scale factor was 2. So 12 times 2 is 24. For whatever reason, I said 3 plus 4 was 9. Okay, but I know it's 12. So that's the information about perimeter. Let's see what's happening with area. Area of triangle ABC. Okay, that's this little small one right here. I'll just draw it here so we can see. This is 3 and 4. So area of a triangle, remember, is 1/2 base times height. So this is just 1/2 3 times 4. 3 times 4 is 12. Half of that is 6. So the area is 6 units squared. So what do you think the area of triangle A prime, B prime, C prime is? I think you're probably all thinking the same number. You're all thinking 12 because we're going to double it. Well, let's find out. So the area of the next one, that's 6 times 8. So 1/2 6 times 8. Okay, this time I'm going to do half of 6 is 3. 3 times 8 is 24. How did we get from 6 to 24? Because our scale factor, here's what's happening. In perimeter, our scale factor is 2. In area, but remember area is units squared. So if I take my scale factor and I square it, I'm going to get K equals 4 for the area scale factor. It's squared. And so look at, if the scale factor for the area is 4, what's 6 times 4? 24. All right, let's look at the problems on the next page. Okay, we're going to use the idea of scale factor to create a proportion. So the important thing about a proportion is that you have to line up all the like parts together. Okay, so do you see how this 8 and the 24, those are corresponding parts even though they're not the same size, and the 6 and the 18 are corresponding parts. So we're going to line up the 8 with the 24 and the 6 with the 18. I could do it that way, or I could when I reduce this, do you see that 6 divided by 6 is 1, 18 divided by 6 is 3. I get 1/3, and this I get 1/3. So the scale factor is 1/3. So when I did it this way, I put everything about the small figure across the top and everything about the big figure across the bottom. I was very consistent. I could have done it like this right as well. I could have done 6/8, and see how I put the 6 on the top, and then so I would put the 18 over 24, and everything about the small figure was listed on this side, and everything on the big picture was listed on this side. So I'm going to be consistent, and if I reduce this, I end up getting 3/4 and 3/4. But do you see it's the same scale factor? It doesn't matter that these aren't the same, it's how I set it up. You want to be consistent. So when we go and solve this problem over here, we're going to get, let's do 8. I usually like to go small over big. This is my preferred way to set this up. The 8 matches up with the X, and the 6 matches up with the 72. So now, once we do this, cross products. Remember we did cross products before? 72 times 8 is something. I'm going to divide by 6, and I'm going to get X equals, and here how I'm going to solve this without doing lots of math. 6 goes into 72, let's see, 10, 11, 12 times, and then 12 times 8 is 96. So the answer is 96. All right. We're going to set up the proportion for these right here, and the best way to do it is to put the like terms together. This side and this side go together, and the 4 and the 10 go together. All right, so keep my colors the same. So if I do small over big, the 4 and the 10 go together. X over X plus 9. I'm going to do cross products. 10X equals 4 times X plus 9. You get to finish this problem for homework. Keep going. And these problems down here, you're going to set them up and set up the like terms together. All right? Good luck.